Well, hello everyone. Thanks very much for tuning in and for listening. My name's Dr. Jeff Lloyd. I'm a microbiologist, mycologist, and biochemist with NICES Corporation. I've been working there now for about 25 years. It's been great. Well, unfortunately, I'm having to talk to you today about flood remediation, and we're very sorry to see all of the flooding and torrential rain that's been taking place across the country recently. But fortunately, we were able to put this program together specifically for Hurricane Rita in 2005, and we've built on it since then. And it's really served the industry very well, and it's really served the consumers very well. So without further ado, we'll get cracking. What we'll talk about today is understanding fungi, potential health effects associated with fungi, moisture in buildings, specific university recommendations regarding what to do after flooding. This is great information. The nicest 10 steps to flood recovery, different treatment options, what they do and what they don't do, and finish up with some conclusions. Well, fungi are living organisms. They grow a bit like a plant, but they eat like an animal. They eat dead stuff typically. And the technical way of saying that is they're saprophytic, but they can be parasitic, using us as a food source, or they can be pathogenic, really harming us or potentially killing us. Normally they're very useful though and important, and as some good examples, bread and beer and wine are as a result of fungal activity, and I love all three of those. The technical definition of fungi is that they're achlorophyllous. They don't contain the green bits that plants have, and they're cellulose-containing organisms, and they're normally filamentous. The ones we'll be talking about today are certainly filamentous. There's two main groups of fungi, the Myxomycota and the Eumycota, and we'll be only focusing on the Eumycota today, not the slime molds, which really live in incredibly wet locations such as lakes and stream beds, that type of thing. And we'll be focusing on the Ascomycotina, the Deuteromycotina, and the Basidiomycotina, and these are basically your mold and stain fungi and your decay or wood rotting fungi. They're the Basidiomycete fungi. But oftentimes it's more interesting to group fungi by what they do rather than their technical classifications. So we'll be looking at mold or surface fungi, discoloring fungi, staining fungi, and decay fungi that physically destroy the structural integrity of the wood. The mold fungi and the stain fungi don't do that. Here we can see a nice example. The top example has some white rotting fungi in it. These fungi tend to leave the wood kind of white and fibrous. You can also see some black staining there. That's mold fungi, and that brings me to an important point. It's very good to note that the conducive conditions for fungi are moisture, the same as the conducive conditions for other wood destroying organisms, and if you've got one, you've probably got the others. Now there are some differences in moisture content that we'll touch on a little bit, but if you can see one type of fungi, you've probably got the others. And you can see how the decay fungi there are destroying the structural integrity of that particular piece of wood. That's a windowsill. The bottom left there, you can see staining fungi. You can see the discoloration there is really in the wood rather than on the wood, and it goes right through the wood. This probably occurred in the forest when the tree was first cut down, and it's old, it's not active, it's not growing in the home or anything like that, and it's really no harm and nothing to worry about. The one on the right there is the surface fungi or mold fungi. That particular example looks like Aspergillus, and you can see the growth is physically raised on the surface of the wood, and it's typically discolored. It's typically black, green, blue, something like that. If you see white and yellow or brown, that can be decay Basidiomycete fungi. We'll have a look at that. Fungi do have some potential health effects, and a big one is structural failure. Decay fungi destroy the structural integrity. As little as 2% wood weight loss, which is not detectable, can give as much as 50% strength loss. This balcony in California fell off of this building due to fungal decay and killed the students that were on the balcony, unfortunately. There are other potential health effects associated with fungi. Mold spores, for example, that are airborne. They're really similar to pollen grains, and they're foreign organic materials, so our body tends to react to those, considers them as antigens and reacts to them in the same way that we do to pollen, and so people can suffer from hay fever type symptoms when they're exposed to mold spores. The same is also true for decay fungi. Some fungi can also be parasitic and pathogenic, meaning they grow on us and use us as the food source. And some fungi do produce mycotoxins or poisons in the fungi, so it's a good idea not to eat moldy materials. That's something that, when you buy bird seed or corn for the deer or something, sometimes that's not tested for some of those mycotoxins, but sometimes it is. So you'll see, guaranteed 99% free of mycotoxin, and that's a good thing then. But be careful about giving your kids animal feed and bird seed or peanuts and stuff that are bought for the birds rather than for human consumption. Here we can see a nice example of the true dry rot fungus, Serpula lacrymans. This is a big time sporulator. This fruit body is producing millions and millions of spores. You can see that cobweb there is actually covered in so many millions and millions of spores. It looks like brick dust. It's a red cobweb. And obviously, if you do suffer from fungal allergies and fungal spores can trigger your allergies, this would be a big one. So it's not just mold fungi that do that. Basidiomycete fungi can do that too. And here's a couple of examples. The fungus on the right there is the fly agaric. That's Agaricus an Agaricus fungi. And your grandmother told you not to eat that. So it's poisonous. If you see it growing in the garden, don't eat it. You know that, so no big deal there. And on the left there, you can see an example of a fungus growing in the lungs there. That's Agaricus fumigatus, and it's the causative organism of farmers' lung. And farmers that work with moldy straw and moldy hay, they'll sometimes inhale those spores that can grow in the lungs and can be dangerous. Fortunately, treatable by modern antibiotics. Well, the requirements of fungal growth are really similar to the requirements of human beings. So we like to live in a nice home with comfortable temperatures, etc. And so fungi do too. You've got to have the presence of the organism there in the first place, but really consider fungal spores to be ubiquitous in the environment. They're everywhere. Okay, so they're there already, just waiting for the right conditions to grow. Food, you've got to have a carbohydrate source. But most materials in a home can provide that carbohydrate source, whether it be wood or cellulose on sheetrock, or even some building materials supply other nutrients for fungi, such as calcium in concrete and insulation materials. Fungi have to have air. They're aerobic organisms. They need oxygen to breathe. They have to have nutrients, certain vitamins and minerals. I mentioned the calcium already, needed by certain decay brown rot fungi. They like a nice comfortable temperature range. They can't grow below freezing, and they can't really grow above 100 degrees Fahrenheit. And they don't like certain inhibitors. So we'll be talking about different treatments that can kill and prevent fungi. So obviously they prefer the absence of those materials for their healthy growth. But if we think about all of those things, the most important thing that we've got most control over in our homes is moisture. Okay, fungi will grow on materials if it's wet enough. Okay, so if you have to remember anything from this presentation, remember this. Okay, fungi need moisture, and typically in our homes, the materials are not wet enough to support fungal growth. So when I say wet enough, exactly what I mean? Well, mold fungi need a wood moisture content of more than 20% or more. And so when you buy kiln-dried lumber from the builder's yard, Kiln dried means it's specifically dried to less than 20% less than to 19% or less. So that KD stamp on the lumber means 19% or less. So it can't go moldy, it can't support fungal growth. And typically a relative humidity of less than 80% is not going to support fungal growth. Now sometimes if you really crank the AC in a home, you can cause condensation at lower moisture contents, lower relative humidities than that, and we'll touch on that a little bit. But if you remember, 20% moisture content and 80% relative humidity, those are real good numbers. And then for the decay fungi to grow, they actually like it slightly wetter. The wood needs to be above the fiber saturation point, so free water in the wood cell lumen, and that means it needs to be about 30% moisture content or above. Now, if wood gets wet in very heavy rainfall, etc., typically it goes up to as much as 100% moisture content, which is the same moisture content in the living tree when it was first cut down in the forest. Okay, just to give you another number there. And unfortunately, wet happens. Wet happens in homes as they're being built, and wet happens after they've been built for various reasons. And here we can just see some new construction examples. The top left in the Pacific Northwest, that's a cross-laminated timber building, and that very highly polished polyurethane floor is not that, it's actually the 2 inches of freestanding water on the surface there that you can see. And then 2 different homes in Knoxville, Tennessee, East Tennessee, where I live, where the wood has been essentially flooded by very, very heavy rainfall as the construction was going up. So really not anybody's fault at all, just really bad weather, and it's very important to get these things dried down as quickly as possible after this happens. Here we can see a rainfall map of the United States, so you can see the high hazard areas, you know, and the examples I showed you were Knoxville, Tennessee, in the middle of the eastern United States there, and the other one was in the Pacific Northwest, so you can see very wet areas. But really we've got areas like southern Mississippi and Louisiana, which are really the wettest parts of the southern United States. In existing buildings, we can really categorize moisture in 3 different ways. Rising damp, which is where the wet ground, moisture from the ground conducts up through capillary action basically into a concrete block or brick, and then into sill plate and up further into the structure. Building code requires a certain height above grade and a slope away from the house, but oftentimes houses are not built to code, or they over time they are no longer meeting code with landscaping changes, etc. Penetrating damp is basically when you've got a leaking pipe or a hole in a roof, or gutters blocked and you've got water running down the house and then getting into the home. And then condensation. I put condensation in bold there, not because it's more important, just because it's more insidious. It's harder to identify, and typically it's only there for certain times of the year and with certain types of activity, so it will come and go. So you might come into a home, find a bunch of mold or even decay fungi, but the wood's relatively dry and you kind of scratch your head and you can't work it out. And you have to think, well, it could be condensation, and it might be having this problem just in the summer, or it might be just having this problem just in the winter, and we'll look at that. When you do anything with fungi, or I would suggest any wood destroying organisms, make sure you have a wood moisture meter. This particular one I like, the Tramex, and there's a cheaper one made by Ryobi. These are capacitance meters, which I prefer to the pin type, the conductivity meter, and I like these because they can actually measure wood moisture content behind sheetrock, so you can actually scan a wall relatively easy and non-destructively to determine what the wood moisture content is behind that sheetrock. And then the equipment on the left there is a relative humidity meter. It will tell you what the humidity is in a crawl space or in a home, but it's also got a temperature test on there as well, and it will self-calculate the dew point. And the dew point is important. It's the temperature at which you get condensation Here we can see a glass with cold water, and so it's wet on the surface. The example I like to use is a bottle of cold beer taken from the refrigerator on a sunny day. It will sweat, the same deal. And dew point's important, and it goes hand in hand with relative humidity because of condensation in especially crawl spaces due to air conditioning use. Most people don't realize, but the safe temperature to use air conditioning in the southeast is probably about 76 degrees Fahrenheit. So if you crank your AC to 70 degrees Fahrenheit, you're probably causing a problem in your home, and I'll show you some of those problems. Here's a damp identification chart. It's kind of like a detective chart for determining moisture content, and you can sort of look through this at your own time. But basically, you can determine through moisture meter pattern, obvious visible signs with moisture content, etc., the type of moisture. And if you can identify the type of moisture, that will help you identify what's causing it and where it's coming from. So are you looking for a leak, or are you looking for condensation that happens just at one time of the year, for example? Here we can see an example of summer condensation. So the relative humidity outside in the summer is relatively high. It might be 80 or even as high as 90% relative humidity. And then the temperature inside that home would be cool with the use of air conditioning, and if the air conditioning is used too much, it could be cold. And if you think about a thermostat on a wall, okay, that might be set to, let's say, 72 degrees Fahrenheit. Well, the floor temperature is probably only 70 degrees Fahrenheit because warm air rises, cold air sinks. So your floor joists in that subfloor are going to be cold. And if that temperature is below the dew point, you will get condensation in that crawl space, and that will then lead to mold growth and fungal decay. One of the reasons for putting plastic down on crawl space, on the dirt inside crawl spaces, is to reduce the relative humidity in the crawl space. But if you've still got cross flow ventilation, that's great normally for most of the year, but not in the middle of summer when you've got very high relative humidity. Fungi in crawl spaces will typically look like this. This is aspergillus, I think, growing on this particular wood. You can see the insulation, and these are the joists. The wood moisture content there is probably about 22% moisture content to give us that growth. Not really wet enough for fungal decay, but certainly wet enough to create an ongoing mold problem. So best to be avoided if we can. If the moisture content gets a little bit higher, then we start to see not only mold growth but fungal decay. And this was a crawl space. This was a home that I went into that had a spongy floor. As part of a home inspection, you could bounce on the floor, and so I went into the crawl space, which I was going to do anyway, of course, to look at why they had a bouncy floor. And all of the floor joists were broken, and the reason they were broken is they all had fungal decay. And this is the classic brown rot fungi. You can see the cuboidal cracking there and the brown discoloration of the wood. Very classic with brown rot fungi. And brown rot fungi include, for example, the true dry rot fungus and also the water conducting fungi, but also lots of other fungi, Coniophora and Gliophilum, things like that. So very fun group of fungi, but they really cause a lot of damage very quickly, actually. So best to avoid moist conditions. And here we can see the opposite kind of problem to condensation. Here we can see in the winter months, now we've got a reversed situation. It's very cold outside, but it's wet and warm inside. And how wet inside will depend on, whether people are hanging washing clothes to be dried, people taking showers and not having good ventilation or air extraction, cooking, generating moisture, etc. And most people don't realize, but a family of 4 will typically produce about 12 gallons of moisture in a home per day. So if you don't have ventilation, that 12 gallons per day can build up and start to cause moisture problems. Fortunately, in the US, we're typically fairly dry in the winter months. But if we don't have good ventilation, or if we don't have any ventilation, then we'll really start to get problems, and we'll see things like this. And this is mold on sheetrock now, And if you get black, wet, slimy sheetrock, there's a good chance it's one of those fungi that produces a mycotoxin, and the best example is Stachybotrys atra, the so-called toxic black mold, and obviously you don't want that, and it's a good idea not to eat moldy sheetrock. Okay, how do you fix condensation problems? Well, it's basically more heat, more ventilation, better insulation, or combinations thereof. So if you've got a heat source, make sure it's a dry heat source, one that's not producing moisture. The ones that do produce moisture in heating typically produce carbon monoxide as well, so they're never something you want to use in a home. And making sure your insulation is good in the walls is great, and having some form of ventilation is good. Or if you can't have enough ventilation, or if it's really cold outside, so you just want to try and avoid having windows and doors open, for example, the use of a dehumidifier is a good idea. And running air conditioning, an HVAC system during the summer, will give you dehumidification in the home, but typically not in the crawl space and the wall voids. So, bear that in mind. A nice place to look for insulation and condensation issues is in bathrooms in the corners of walls, and I'll quite often see a black stripe in the corner of the wall, and the reason being it's one insulated wall meeting another insulated wall, but when the home was built, the corner where those 2x4s met or 2x6s met wasn't insulated. It needs an extra bead of foam insulation there, and so you'll quite often get that black stripe. You can also see black stripes on the edge of carpet sometimes where the carpet goes under the kickboard. That's typically where you've got moisture coming from the crawl space and meeting the cold air at the floor from the HVAC system, and that will grow mold around the edge of the carpet and give you a black edge to the carpet. Now we'll really get to the meat and potatoes of this presentation. Now you really understand about moisture and about fungi. We'll get to severe moisture problems, specifically flooding. And flooding can be caused with roof damage and very, very heavy rainfall with hurricanes, for example, or with very heavy rainfall at the same time as tidal swell, rivers backing up, dams breaking, etc. So a whole host of things can cause this type of very, very severe issue. And if the home is not actually physically damaged, which often it is in a hurricane, you can tear roofs off and break windows, etc. But even if it's not damaged in that way, this level of flooding can cause a lot of damage in a home relatively quickly. So the faster you can get it fixed, the better. Here we can see what's happened after the floodwaters have receded, and you can already see you've got mold growth happening here. You might also have sewage contamination when flooding occurs. Drains typically get backed up. The toilets in the home might get backed up if there's septic tanks there, etc. That can cause a problem. So bear that in mind. It might not just be clean rainwater. And you've got about a week to take action before you really start to get some serious problems. Okay, that's not a long period of time. Okay, this particular picture was probably taken about 2 weeks after the floodwaters receded there by the level of fungi I can see growing, but the level of fungal growth depends on temperature as well. So if this was in a cold time of year, in a cold environment, the fungal growth would be much slower than if it was really very, very warm, hot climate, then it would be much faster. So you don't have long. The faster you can act to dry the structure, the better the homeowner will be. Be sure to check state laws if you're going to do this commercially. So typically the types of products listed here are non-restricted use preservative systems, so they're considered safe enough for homeowners to apply themselves. But obviously it's best if you can get a professional application done, and applicators need specific licenses. So do check your state. Some states have specific licenses. Most states have specific licenses for wood destroying organisms. Some have a different license for mold remediation. So depending on exactly what you're doing and what you're claiming, you'll need to make sure you've got the appropriate license. Okay, so here are some good tools that I'd like to point you to. Okay, and along with this presentation, we also have some literature that goes with it, including these 3 documents. Okay, one is from the University of Tennessee, one is from Louisiana State University, and one is from Mississippi State University. And these documents were put together after very severe flooding in the states, and they list the things that you should do to avoid further damage to your homes. These are very good for homeowners to use because they lay out the information specifically for homeowners, so homeowners can understand what they should consider and what they should and should not do. But they're also very good for professional pest control applicators because it's something that you can use to help educate your homeowner as to what it is you want to do in their home so they understand what you're doing and why. So very good sales tools, these particular documents. So let's talk you through now the 10 steps to protecting recently flooded structures from moisture and fungi. Okay? You have an opportunity to use your expertise to protect your customers' homes and health. Okay? There's a genuine need to help protect structures from fungal damage and to reinstall a termite barrier. And personally, I would prefer professional pest controls companies get involved because there's a lot of fly-by-night companies out there that will come and try and sell all sorts of things for homeowners to fix their flooded homes, and oftentimes it's not applicable approaches, and it's not even products that are going to be effective, and I'll show you a couple of examples. So step 1, first of all, make sure the structure's safe. Okay, don't go into a structure if the roof is caved in or if the basement's still flooded. Be careful about how that's pumped out. You don't want the foundation walls to be collapsed, so it's better to kind of let it subside slowly. So make sure the structure's safe, and then wear the appropriate protective equipment. You're going to be potentially working with a lot of sewage contamination, with a lot of mold spores, etc. So appropriate personal protective equipment is absolutely necessary. Even though you're not applying any protective chemicals yet, you still want to wear the appropriate personal protective equipment. And make sure the electricity and the HVAC are off. There's a good chance you won't have electricity back on in the home anyway, and you'll have to bring in your own battery-powered lighting. But if there is electricity to the home, make sure it's turned off. And I would suggest turning it off even if you don't have electricity, just to make sure it can't come on again by accident whilst you're in there doing something. Then remove all of the flooded material, all of the physical debris, the mud, clothes, furniture, everything else that could be very, very haphazardly strewn around the structure as it floated in rooms and then sunk again. So remove all of that. Okay, that's going to help you do appropriate treatments. It's going to help you dry the structure as quickly as possible. Anything you want to keep, if you've got a garage, you can put it in. That's great. But a lot of these materials are probably going to be discarded. Then thoroughly disinfect the areas where you're going to be working. Okay, if you suspect any sewage contamination, if you've had rodents or anything in the structure whilst it was flooded or after it was flooded before you could get to it to clean it, make sure you appropriately disinfect the material. One example here you consider is a disinfectant, sanitizer and viricide that's labeled for pretty much all types of pathogenic organisms that home could be contaminated with. Sometimes it makes sense to do a treatment after you've removed some of the materials, but then continue cleaning, remove more materials, and then you might even do another treatment after you've removed additional debris in the home. Step 4, cut out all of the sheetrock to just above the flood line. Okay. Now sheetrock typically comes in 8x4 sheets, so if you've got 2 feet of flooding, 3 feet of flooding, you might just take it up to 4 feet because that will allow you to replace with a whole new board, and that will be easier and lower labor costs. But remove the sheetrock and remove the insulation. This will allow the wood studs to dry out as quickly as possible. Okay. If you've already got significant mold problems, okay, if all of those studs are black and you can visibly see that, we would recommend treatment with a product such as Mold Clean, which will remove that fungal staining and remove that surface mycelial growth. Okay, you apply that product. You can physically scrub the surfaces. If the home is still really wet and flooded, you can even pressure wash in certain situations, although typically I don't recommend that. You know, a very stiff brush, brushing that after application, and then a rinse off will normally do a very good job of cleaning that material. Typically, you shouldn't use bleach. Bleach is an EPA registered pesticide and it's not labeled for that application, and it also contains a chlorine stabilizer, which is caustic sodium hydroxide, which is very corrosive to metal fixtures and fittings. So you'll see in some of those university recommendations not to use bleach. The Mold Clean product contains an oxidizing agent and a surfactant to really help clean the surfaces as well as decolorize the staining. Step 6, we're really trying to protect the wood as quickly as we can. As soon as you've removed the sheetrock and removed the insulation, you can do an application with a product like Boracare with Mold Care. The wood does not have to be dry. Do not wait for the wood to dry before you do the application. It's over that drying time that the wood will start to grow surface fungi and really start to look bad. So the sooner you do this application, the better. The application is designed to kill and prevent fungi. So any fungal spores on the surface of the wood, any small amount of growth that you've already got there, the treatment will kill that growth. And then the Mold Care, Boracare part of that are synergistic with the control of surface fungi or mold fungi, and the Boracare part is there to stop wood destroying insects and the decay fungi, and that will diffuse very deeply into the wood, especially at higher moisture content, in order to control those organisms, both anything that's there now, but also going forward for the future. Is going to protect long-term protection for that particular structure. What you want to do is to treat all exposed wood using the Boracare with Mold Care at a 1+5 dilution. So the co-pack you see here, 1 gallon of Boracare and 1 pint of Mold Care. The Boracare is at a 40% active ingredient concentration, 40% borate, and the Mold Care is at a 80% concentrate of the quaternary ammonium compound, diacyl dimethyl ammonium chloride, and those two things are mixed together for the application. The wood can still be wet when the product is applied. As I mentioned, please don't wait for it to dry out. Other products that could be considered are typically not very effective. So if you want to consider something else, look very carefully at first its EPA registration, make sure it's labeled for that application, make sure it's a legal product, and then also check the efficacy data to know that it's effective. We've done testing on a couple of widely available products and have found them to be completely ineffective in these types of high hazard type applications. And I'll show you a couple of those in just a second. So in this particular test, we've used a hardwood and we've dipped the hardwood in one particular product on one end, in this case a retail type product, and then the other end we've dipped in a mixture of Boracare Mold Care, and then we've placed this piece of treated wood in a moisture high humidity environment, what we call our mold chamber or mold testing incubation chamber, and we've held that for about 1 month, and we can see there that the concrobium is ineffective at controlling the surface fungi or mold fungi. In this particular case, I think we've got some aspergillus growing there, maybe some trichoderma, and the Boracare with Mold Care has been very effective at stopping the growth of the organisms in this particular case. We can see here a similar situation. Here we've treated an entire piece of wood with one product, In this case, Shockwave is the brand name, and the other piece of wood, hardwood again, we've treated with Boracare with mold care, and then the same incubation, typically 80 to 90% relative humidity at about 75 degrees Fahrenheit, and we incubate that for a month and then look at the severity of the fungal growth on the surfaces. And we can see the Boracare with mold care very effective at preventing that growth during that time period, and the other material is not effective. You wouldn't want to use that in such a situation. These types of tests are also done as standard tests, and we've carried out efficacy testing with the USDA Forest Products Lab, for example, and they've shown that the Boracare with mold care is a very effective combination for the control of these types of organisms. And the reason we use this combination is because of that. Each product by itself is less effective at controlling these organisms. Step 7 is to consider your termite protection. Flooding is really a bad event, and that will typically disrupt just about any type of termite preventive management system you've got in place on a home, whether that be bait stations or a soil termite treatment, for example. If you've opened up the structure to expose the sill plate and the wood in the structure, you've got a really fantastic opportunity to install a termite protective system that's really designed to be permanent within the structure. So you can do a Boracare 1+1 dilution and follow the label in section 6 of the Boracare label and treat all of the wood to a height of 2 feet. In treating the wood, the label requires any wood where you can only treat 2 surfaces. You're required to do a double application and a single application if you can hit 3 or more faces. So an interior wall, sill plate and stud wall, for example, typically need a single application, but an exterior wall, the sill plate would require 2 applications because you can only get to 2 faces of the sill plate. And if you've got married studs, we can see some married studs in this picture on the bottom right. That also requires 2 applications, and you typically find married studs around doors and windows and at the corners of structures where you have walls come together. Again, that requires 2 applications with a 1+1 Boracare dilution in order to give the full subterranean termite protection per the Boracare label. If you want that treatment to be part of if you want it to receive a termite letter, if you plan on selling the home and you want to show that a treatment has been done, it is essential that that treatment is carried out by a professional pest control applicator. So do talk to your pest management professional in order to get that treatment carried out if you're not having the other work already done by a pest management professional. He will be able to do the work correctly, and they'll be able to then give you a termite letter as appropriate. Step 8 is to properly dry the structure. Now, if you've got electricity again, that's wonderful. You can run the HVAC, and if you've got ceiling fans and you can click the fan on the HVAC, that will do a slow job of drying the structure. And you don't have to dry it too fast because you don't want to cause wood shrinkage and other issues with over drying a structure. If you've got access to dehumidification, commercial dehumidifiers, for example, combined with fans, that's wonderful. And typically you want to set your dehumidifier to 50% relative humidity, a 50% relative humidity. If you set it drier than that, it won't make it dry faster, but it will over dry. And typically the safe moisture content for wood in the safe relative humidity in a home, the healthy relative humidity in a home is between 40 and 60% relative humidity. And if you dry at 50 and take the home down to 50% relative humidity, that will allow the continued drying, and you've got your fans running hopefully, so you're moving the air around as part of that dehumidification. If you don't have access to electricity, you need to think about chimney effect drying. So if you've got upstairs windows, open upstairs windows and downstairs windows, or a garage door, so you've got flow, ventilation through the structure to dry it out. Again, more ventilation is better. And if you've got battery operated fans, for example, that can also help you. Okay, but drying out the structure is very important, and you want to dry it out really, you know, as quickly as is relatively as you're able to do. Step 9 is again use your moisture meter. Okay, you've got this structure dried out now. You've treated it to prevent wood destroying organisms and surface fungi, mold fungi. Now you want to reinstall the insulation and put the sheetrock back, and then hopefully move furniture, etc., back into the home. You do not want to enclose wall voids again if the wood is still very wet, because that moisture, that relative humidity in the wall void will move to other parts of that wall void, other parts of the home even, and can potentially cause fungal problems in those other areas that you may not have treated and protected. Okay, so you want to make sure the wood is back down to 19% moisture content or less before you put the insulation back and then the sheetrock back. Okay. Step 10, you can consider odor issues. Oftentimes you've got organic debris been deposited in the home, it's been damp, etc. So DSV, we talked about that earlier. Hopefully you've done a disinfectant type treatment in the structure already. That will kill the bacteria that often cause odors. Okay, so that's typically a good thing to do, and some of those bacteria can be pathogenic, so we want to kill those so we don't harm people. There's no residual protection from that. So once you've done the disinfection type situation, you know, you've killed the bacteria. If you've still got a damp situation, you've still got organic debris there, you could still have some ongoing odors. And so other type products, odor eliminating products, or organic digesting products like Bacazap or Foam Fresh can also be helpful to you. Let's have a look specifically then at the different treatments and what they can and can't do. Dry the wood and materials first. That's the most important treatment that you can do. Okay, getting rid of the moisture problem and getting the relative humidity back below 80% and getting the wood moisture contents back below 20% will kill mold fungi, stop mold fungi from growing, and also stop most decay fungi. Okay, really it's the best thing you can do long term. Detergents and stain removers by themselves are not very good at killing or preventing fungi. They're really just there to clean and remove stains. Okay, there's also no residual effect. So if you clean everything and it stays wet, fungi will grow back again. Okay, so you need to clean and then treat, or clean and then treat and then dry in order to avoid problems. High temperatures, heating to above 130 degrees Fahrenheit will kill everything. If you haven't got power there, it's difficult to do that. And again, there's no residual protection, so you do need to dry the structure, or heat and treat and then dry, for example. Moldicidal paints are sometimes used in bathrooms. These are really designed for exterior millwork type treatments. They contain a film fungicide in the paint to stop fungi growing in the paint film. They work quite well on millwork, and they'll protect the paint film, you know, for 5 years, and you'll often see a 5-year warranty, or resistant to mildew, for example, it might say on the paint can. It's really not a good thing to do to be painting wood in a crawl space or inside walls. What that typically does is, first of all, it won't stop any fungi growing in the wood. It only stops fungi growing in the paint film, number one. And number two, if the wood is still wet, or if it gets wet again, it reduces its drying rate and typically makes it rot faster. So not a good thing to do. You know, use it on exterior millwork, or maybe in a shower ceiling or something, and it's got some limited good use in those situations. Fungicides, They can kill materials or they can prevent regrowth of the materials, or both. You have to carefully read the label. What you want to do, my recommendation, is to find a fungicide that will kill and prevent and give you some residual protection whilst the structure is properly drying out. So read the label carefully. And then borates, there's a lot of different borates out there. They can kill and prevent decay fungi and insect infestation, but they're not labeled, nor are they effective at stopping surface fungi or mold fungi. So combining a fungicide with a borate, in my opinion, is the best way to control all of those wood destroying organisms and the mold surface fungi. Continuing on with treatments and looking at label issues. If you're a professional doing applications, you will know this. Okay. If you're a homeowner looking at what to do and how to do things, this is very, very important. Okay. If it's not EPA registered for the application, okay, it cannot be sold for that application. It cannot be marketed for that application. Okay, that's not legal to do that, and you don't know that it would be effective at doing what a company is claiming if it's not EPA registered for that use. You also don't know if it's safe for that particular use. Typically, EPA will look at both the efficacy and performance of a product and the safety in its label uses to make sure that you get something that works and isn't going to cause more problems or harm to applicators or homeowners. For sanitizers, such as DSV, for example, read the label. They are not normally designed for wood, and they do not provide residual control. Fungicide containing paints, I already mentioned the issues there. They stop fungi from growing in the paint film. They do nothing really to protect the wood, and they can actually make the situation worse. And if it's wet enough for mold, there's a good chance it's wet enough for fungal decay, and it's also wet enough, mold is a sign of a conducive condition for all those wood destroying insects as well. So use a product that takes care of all of these problems at the same time. So what does DSV do? Well, I mentioned it's a disinfectant, sanitizer, and viricide. So it makes hard surfaces safe from pathogenic organisms by killing those pathogenic organisms, and it's effective against fungi, bacteria, and viruses. You can see all of the organisms that it's labeled to control on the label there. It doesn't provide residual protection, and on porous surfaces like fabrics, curtains, a sofa, for example, couch, then it can be used as a deodorizer, but it can't necessarily then kill the 99.99% of all known organisms, which is a typical claim I see for those types of products. Okay, so good for hard surfaces, good for disinfecting, floors, etc. in the home. On fabrics, etc., really consider it more as a deodorizing type application. Boracare or Timbor, great borate products. These products are good at stopping wood destroying insects and wood destroying fungi, the decay fungi, but they can't control the surface fungi or mold fungi. Boracare with mold care has all of the benefits and penetrating capabilities of the regular Boracare product, and it's combined with mold care, our surfactant, bactericide, fungicide, in order to control mold fungi. So the two products together are synergistic against the surface fungi and mold fungi, but you also get the control of the wood destroying insects and wood decaying fungi with the combination of those products. Now, if you do want full protection against subterranean termites as well as the other wood destroying organisms and the surface fungi or mold fungi, then do carry out a Boracare application at a 1+1 dilution. The Boracare with mold care is designed as a 1+5 dilution. So one of these co-pack units here is mixed with 5 gallons of water for application. And just incidentally, 1 mixed gallon will treat 400 square feet of surface area, up to 400 square feet of surface area. So it's really quite a cost-effective treatment to do. It's quite a nice dilution that you have there with this professional concentrate. Boracare is the borate technology using the maximum solubility and diffusion. So this is what's really going to give you that penetration into the wood over time. Really fantastic track record with this product. It's been used now for subterranean termite control here in the US for 30 years, has data over the last 80 years as an active ingredient in other parts of the world. And then that's combined with the mold care sanitizer, disinfectant technology. This is similar to the DSV material, but at a much higher concentration. This is really a professional concentrate that's designed to kill surface fungi and prevent material from growing back whilst the structure dries out. So a good combination of those two technologies. By the way, if you're interested in efficacy data for any of the things I've talked to you about today, do contact us. We've got a lot of information, including data generated by the USDA and other independent laboratories. Very happy to share that. Here we can see a nice application of Boracare mold care on a single piece of wood. So you can see the untreated, unprotected wood versus the treated wood. And here we can see an application of the Boracare mold care on sheetrock. This was a study done by USDA, the Forest Products Lab, a few years ago. And they actually inoculated both wood and sheetrock materials with different types of fungi to look at the level of control. So you can see the spores that were applied to the surfaces here, and untreated control samples easily grow the mold that's applied, whereas the treated materials are protected during the test. I mentioned controls wood-destroying pests, wood-destroying organisms. These are the typical ones we see: powder post beetle, true lictid powder posts, false powder posts such as Heteropostricus, flathead borers, old house borers, drywood termites, very important around the coastal areas and southern areas of the United States, dampwood termites, carpenter ants, and decay fungi. And then the subterranean termites up there in the top right. I mentioned there's a different label rate to control the subterranean termites. That's the 1+1 dilution as opposed to the 1+5 dilution. So how much do you need? Well, I mentioned that 1 mixed gallon will treat 400 square feet of surface area, but the good news is you don't have to calculate it all for the home yourself. Do contact us. We do have spreadsheets that you can use to work out how much you're going to need, and we're happy to help you. Give us a call. So let's finish up with some conclusions then. Water is enemy number 1. Most construction materials can support mold and fungal growth. If it's wet enough for mold, it's wet enough for decay and the initiation of insect infestation. Mold is a simple indicator of more problems to come. Okay, so if you see mold, if you see surface fungi, you know it's been wet enough to support wood destroying organisms as well as just the non-wood destroying organisms. Okay, it's a good sign of a conducive condition. You can sanitize surfaces with products like DSV. You can remove discoloration with cleaning compounds such as mold clean. If you want to control all fungi, including mold fungi and decay fungi, and you want to stop wood destroying insects, then treat with something that's labeled to kill and prevent all of those organisms. To my knowledge, the only material that's independently recommended and the only one that's labeled to do all of that is Boracare with mold care. Ultimately though, nothing can prevent fungal growth permanently if the materials remain continuously wet. All the solutions involve mechanisms for removing and keeping water out. So with a flooded structure, make sure you get it dried out, and with regular homes, do make sure the relative humidity is less than 80%, and if it's going to be higher than 80% in certain areas such as crawl spaces, make sure you're taking appropriate steps to control that moisture and keep it lower than that 80% moisture content, and the wood less than the 20% moisture content. Thanks very much. Just finishing up, I will give you some numbers and some contact names and emails. You're very welcome to contact me, Jeff Lloyd. My email address is there, and my cell phone number. And then the rest of our technical team is given there. Jamel, Sarah, and Jay Wu. We're all here and at your service. Thanks very much for listening. I do hope we've helped you as a consumer, or we've helped you as a professional help your customer in these tragic circumstances. Thank you very much. I hope you found this presentation useful. We'll sometimes give this to association groups and other customers. If you've watched this and you think it would be useful to see the presentation in person and to discuss some of the materials and have the opportunity for questions and answers, please contact us. We're always prepared to consider doing this locally for our customers. Again, thank you very much.